If Neptune and Uranus were to switch places, the implications would be profound and fascinating. This thought experiment takes us into a realm of planetary science where orbital dynamics, atmospheric chemistry, and solar system formation come into play. The switch isn't merely a case of swapping two planets' positions. It's a complex scenario that would ripple through the entire solar system, affecting everything from planetary orbits to the chemistry of atmospheres and even the solar system's stability. Let's dive into what this dramatic shift could entail. How could it happen? The idea of Neptune and Uranus switching places isn't entirely out of left field. The NICE model, a leading theory of planetary formation, suggests that in the early solar system, the giant planets were much closer together. Through a process of migration, they gradually moved to their current positions. During this chaotic period, it's conceivable that Neptune and Uranus could have exchanged orbits due to gravitational interactions or close encounters with each other or other small celestial bodies. Such an event would have required perfect timing. These gravitational interactions, often assisted by resonances in the planet's orbits, could have nudged them out of place and caused a switch. While it's plausible in theory, the energy required for this massive shift is immense, making it a rare and unlikely event in the later, more stable solar system. However, if such a scenario had occurred early on, it would have reshaped the very fabric of our planetary neighborhood. What if it did happen? Imagine if Neptune and Uranus suddenly traded places in today's solar system. First and foremost, the new orbital dynamics would change everything. The gravity of these planets exerts influence not just on themselves, but on everything around them, from other planets to smaller objects in the solar system. Orbital chaos. The switch would likely disturb the orbits of small bodies like asteroids, comets, and even the outer planets. A key zone that would be affected is the Kuiper Belt, a region filled with icy bodies beyond Neptune. Right now, Neptune's gravity helps shape and influence the Kuiper Belt. If it moved to Uranus's current orbit, its gravitational reach would weaken in this distant region, potentially destabilizing many of these icy objects. Some might even be flung inward, posing potential collision threats for planets closer to the Sun. Atmospheric shifts. One of the most interesting changes would be in the atmospheres of Neptune and Uranus. These planets have similar compositions, dominated by hydrogen and helium, but there are crucial differences. Uranus is known to have more methane in its atmosphere, giving it a greenish tint, while Neptune appears bluer due to different trace gases like hydrogen sulfide. If they switched places, Neptune would receive less sunlight in Uranus's current position, potentially causing it to lose some of its vibrant blue hue. On the other hand, Uranus might warm slightly in Neptune's orbit, altering its atmospheric chemistry in unpredictable ways. Some theories even suggest that this shift could trigger volatile reactions between gases in their atmospheres, releasing heat and further changing the dynamics. Internal heat and magnetic fields. A significant consequence of the switch would be changes in the planet's internal heat generation. Neptune emits more internal heat than Uranus, but in Uranus's colder orbit, this heat might dissipate faster. This could lead to a decrease in atmospheric activity and a cooling of the planet overall. Meanwhile, Uranus, with its famously tilted magnetic field, could experience a shift in its magnetic dynamics due to its new distance from the Sun. This might cause changes in the behavior of their magnetic fields, which are already quite peculiar in both planets. Moons in disarray. The moons orbiting both planets would also face consequences. These moons are in stable orbits around their parent planets, but a sudden shift in the gravitational field could destabilize these orbits. Some moons might collide, while others could be ejected entirely from their parent planet's gravitational influence. It would be a chaotic period for the satellite systems of both Neptune and Uranus. Trojan asteroids. Neptune is home to Trojan asteroids, small celestial bodies that share its orbit. If Neptune moved to Uranus's current position, these asteroids would be displaced, scattering across the solar system. This could create a new population of wandering asteroids, potentially altering the future landscape of planetary formation and collisions. Impacts on solar system stability. One of the more long-term consequences of a Neptune-Uranus switch is the potential destabilization of the entire solar system. The current configuration of planets is the result of billions of years of gravitational balancing. By disrupting the balance, other planets' orbits could gradually shift over millions of years. While Earth and the inner planets might not see immediate effects, the long-term stability of the solar system could be in jeopardy. A cosmic dance of chemistry. Beyond the gravitational chaos, the atmospheric changes would offer an even more intriguing dimension. Currently, Uranus and Neptune both possess atmospheres rich in methane, but the different solar radiations at their respective distances lead to subtle differences in their atmospheric chemistry. Methane, for example, reacts with sunlight to form hazy, orange mist in Uranus's atmosphere, giving the planet a greenish hue. If Neptune took its place, it would receive more sunlight, potentially causing a similar reaction and changing its appearance to a greenish blue. On the flip side, Uranus, now farther from the Sun, might lose some of this haze and become a deeper blue, resembling Neptune's current look. This change wouldn't just be aesthetic. The atmospheric pressures and temperatures at these different distances from the Sun could cause volatile elements to react with each other, potentially releasing heat through exothermic reactions. This warming could alter the atmospheric dynamics, creating new weather patterns and storms that we haven't observed before. A peek into the past. Interestingly, some models of the solar system's early formation suggest that Uranus and Neptune might have actually switched places once before. Steve Desch, an astrophysicist, proposed that the planets formed much closer to the Sun and later migrated outward. During this migration, they may have swapped orbits, explaining some of the inconsistencies in how we understand their formation. If this switch did happen billions of years ago, it could have been part of the solar system's early turbulence before it settled into its current configuration. The grand conclusion. Swapping Neptune and Uranus would be more than just a simple game of musical chairs. The consequences would ripple through the entire solar system. From chaotic orbital shifts to drastic atmospheric changes, the switch would disrupt the delicate balance of gravitational forces that have held our solar system together for billions of years. It would give scientists a wealth of new data to analyze, but it would also remind us of the fragile dance that governs our planetary system. In the end, while the switch is theoretically possible, the immense forces and energy involved make it an unlikely event. But imagining the what-if reveals just how interconnected and dynamic our solar system truly is.